Hello friends, welcome to Code Sutra. In this video, I'll be discussing about Boyer-Moore majority voting algorithm. This algorithm is actually asked in majority of the companies. This algorithm is not at all an intuitive algorithm, but if you understand this is one of the easiest algorithm, and this problem will also teach you how the algorithm can actually reduce the time complexity of any given problem, the importance of DSA and why algorithms are required. Okay, so in this particular problem, say you have an array and you have elements. What is the majority element? A majority element is something which is occurring more than n by 2 times. For example, in this array there are 10 elements. The element that is occurring more than 5 times, that is 6 times, is called as the majority element. For example, 4 here is occurring 6 times, 3 and 6 times. So 4 is the majority element. So how do you find the majority element? Let's go step by step and I will arrive at the solution. The first approach is the brute force approach. What do you do in this? You will choose an element, for example 3, and you will search the entire array. How many times 3 has occurred? How many times has it occurred? It has occurred twice. So is this the majority element? Is it occurring more than n by 2 times? Definitely not, right? Similarly, you will choose 7 and you will go through the entire array from the beginning. Is 7 occurring more than n by 2 times? No, right? Then you go to 4 and you will again check. Is 4 occurring n by 2 times? Yes, it is occurring actually 6 times. So that will be our majority element. But what is the time complexity? The time complexity is of the order of n square. Though it might not be n square exactly, but it is the order of n square definitely, right? Because for every element n, you are again traveling the entire array one more time. So it is of the order of n square. So this is not definitely what we are looking for. The second way is we can use a hash map. How do we do this? For example, we iterate over the array. First element is 3, and what is the count? If it is not there, we will just insert the element with a count 1. 7 again with the count 1. Now 4 again with a count 1. Again 4 is there, so the count will increase. So 3 is already there, the count will increase. Then again we go to 4, the count will increase. So similarly, at the end of the array, the count of 4 will be 6. Again, what do we do? After the iteration of the entire array, we just iterate over the hash map again. And if the value is greater than n by 2, for example, what is the value of 3? 2. That is not the required answer. The value of 4 is 6, so that is the required answer. So we will be returning 4. But this also uses an extra space, right? For example, what if all the elements are unique here except the element that we want? What if all the elements are unique? You will be using again space of the order of n, right? So that is not what we are looking for. So let's go to our algorithm, Boyer-Moore majority algorithm. Say for example, there are two parties, party A and party B. There is an election that is running and you are planning to cast your vote for party A, and your friend is planning to cast his vote or her vote for the party B. Then is it actually required for you to go to the booth? Right? You can sit at home and cancel your votes, right? It is not required for you to go to the election booth and cast your vote. Anyways, it will be cancelled, right? You cast your vote to party A and your friend will cast it to party B. Then you can sit in home and cancel, right? So that is exactly what is the idea here. For example, what is the majority element? See, we have counted just one element. What is the majority element? 4. And what is the count of the majority element? 1. Now here comes 7. So what is the majority element? Though 4 is the majority element, since 7 is coming, does the count decrease? Yes, it will decrease, right? So can we just remove this? Yes, we can remove this. Why? Even though these two are there, even though 4 is occurring here, whatever is there in the remaining, does 4 have to occur 5 times? That is, this array size is 8. Here also 4 has to be the majority element. It has to occur 5 times. So this 4 and this 7 actually doesn't matter because one vote has been cancelled by the other. So that is the idea. What do we do here? We have a majority element and we will have the count. And if the majority element is not equal to this element, we will reduce the count. For example, we go to 7. We go to 7 here. And what will be the count? The count will become 0. Right. So then we go to the next element and the count will become 1. So again we go to the next element, the count will become 2. Again we go to the next, the count will be 1. Again to the next, and the count will be 2. Again we go to 6, the count will reduce to 1. Again we go to 4, the count will be 2, and the count will be again reduced to 1, and again will increase to 2. So though this is not the count of the majority element, it just implies that there is a majority element, and finally whichever is the majority element will be our answer, right? Okay, so let me take you through the code. What do? We initiate the major variable with the first element of the array, that is 4, and whenever the majority element is equal to I, then we will increase the count, and whenever it is not, we will decrease the count, right? We are doing this for all the elements, but one more condition is there. If the count is equal to 0, we will be changing the majority element. Okay, finally we will be returning the majority element. Thank you for watching the video. Please do like, share and subscribe.